Hi students, in this video we're going to go over section 3.3, which is forms of linear equations. We're going to talk about calculating slope, and then linear equations in slope-intercept form, point-slope form, and what vertical and horizontal lines are going to look like, what their equations are going to look like. This is the only section I'm going to create a lecture on from chapter 3. But it really overlaps with some of the other sections in chapter 3. So I hope it's a comprehensive lecture here. A lot of this stuff should be things you have already seen. So just a reminder about the Cartesian coordinate system. We set this up with two number lines at a 90-degree angle. The center where they intersect is called the origin. The y-axis is the vertical number line, the x-axis is the horizontal number line, and they overlap at 0, 0. So we set this up so that we can tell where we are in two-dimensional space just using two numbers. One tells us how far we are sideways, one tells us how far we are up and down. All right, we need two numbers to define any place in two-dimensional space. Similarly, if we're going to try to define a position in three-dimensional space, we would need three numbers. There are other coordinate systems. There's polar coordinates, where you say which angle you are about the center and how far away from the center you are. Okay, again, two pieces of information to define a position in two-dimensional space. We can take our coordinate system into 3 dimensions, and we call it an x, y, and z axis. We can also take the polar coordinates into 3 dimensions as well. So let's just define a few things about linear equations. Linear equations, like all equations in two variables, are going to have infinite solutions, okay, or can have infinite solutions. For that reason, each solution, since we're in two variables, is going to be an ordered pair. And the best way to find a solution is to just pick one value for that ordered pair and get the other value that corresponds. So while it has infinite solutions, each ordered pair is unique in that the value of one of our variables determines the value of the other variable. Okay. When variables are each first in the first degree, we call it a linear equation, and it's going to be a straight line. So let's just do an example. Let's take this linear equation x plus y equals 2. This is an equation in two variables because we've got the variable x and the variable y. It's linear because nothing is being squared, no variables are being multiplied. So if we want to find 3 of the infinite solutions here, we're just going to pick a value for one variable. Let's say that x equals 1, and then we're going to figure out what y equals. Well, if x equals 1, y has to equal 1 also, because 1 plus 1 will give us 2. So that's one solution, is the ordered pair 1, 1. We can pick another value for x. Let's make x 0, then y is 2. So the ordered pair 0, 2 is another solution. We can make x negative 1, and then y is going to be 3. So the ordered pair negative 1, 3 is going to be a solution, and that should be a negative right there. Just pretend that's a negative 1. Okay, so that's how you find solutions to these linear equations. Again, we could pick any value for x in this situation, and we would have an infinite list of these ordered pairs. In linear equations, it is also okay to pick a value for y and figure out what x is. Okay. So sometimes it's better to see the solutions graphically because then we can visualize all the infinite solutions. So for this equation, y equals 2x plus 1, we can find 2 solutions or 3 solutions. And when we plot those solutions on the Cartesian coordinates, we'll find that they make a straight line. Okay, we've got infinite solutions, but they all line up on this straight line. All right. So now let me just talk about x and y intercepts. So the y intercept is the coordinates where the line crosses the x-axis. Our line is going to cross the x-axis, or sorry, cross the y-axis when x is 0, okay? And similarly, the x-intercept is where we cross the x-axis, and this is going to happen when y is 0. So when y is 0, we're going to cross our x-axis. The way to find these is just to find the x-intercept. You can just set y equal to 0 and solve. To find the y-intercept, you can set x equal to 0 and solve. Slope. So let's talk about slope. Each of these lines has a different, let's call it a steepness, and that is what we call the slope. So the slope between any 2 points can be calculated as the difference in the height of the 2 points divided by the difference in the horizontal distance of the 2 points, what we call rise over run, okay? So let's say we have these 2 points over here. Our green point is going to be 0, 2. So x is 0, y is 2. And our blue point is going to be -3, 1. So the x of this point is -3, the y is 1. We can plug that into our formula, take the difference of the y coordinates. So it's going to be 2 minus 1. And the difference in the x coordinates, so it's going to be 0 minus -3. All right. 2 minus 1 and 0 minus -3. When we simplify this, we're going to get 1/3. When calculating the slope and you have negative coordinate values, be very, very careful to remember we are doing a subtraction as part of the formula. So you might be subtracting a negative number, which then becomes a positive number. Okay. Oops. So that tells us the slope or how steep it is between these 2 points. You can imagine if you drew a line between these 2 points, it's not very steep because the slope is less than 1. Given that slope, we can now talk about the slope-intercept form of these linear equations. So our linear equations are going to take on a few different forms. The easiest one to graph is the slope-intercept form. A slope-intercept form occurs when we have solved our linear equation for y. Okay. This happens when we can clearly see the value of y when x is 0, the y-intercept. Okay, so it's called slope-intercept form because we will be able to clearly see the slope and the y-intercept in the equation itself. Okay. So to put this equation, which is linear because x and y are not being squared and they're not being multiplied by each other, this is what's called standard form. We're going to turn it into slope-intercept form by solving it for y. So we'll subtract the 2x and we'll divide by 3. And then we get an equation y equals -2/3 x plus 2. Now this is slope-intercept form. The 2 is the y coordinate when x is 0. Notice when x is 0, this whole term becomes 0 and y becomes 2. So that means we are going to cross the y-axis at x is 0, y is 2. Okay. Now the slope is going to tell us how much we increase our y, so how much we change vertically per 1 unit change in horizontal. So the x is our horizontal change. Every time x increases by 1, everything on this right-hand side is going to increase by -2/3, which means our y is going to increase by -2/3 every time x increases by 1. So that means the amount we rise, our y, divided by the amount we run, our x, is going to be -2/3. Okay. So our y-intercept is there at +2, and we have a slope of -2/3. Okay, which means we're going to go, we can also call it a down 2 to the right 3. Or we could say we're rising -2 over our run, which is a +3. Okay, so it's rise, how much we go up over how much we go sideways. And we're going up -2, which means we're going down 2 and we're going sideways 3. So our slope is a -2/3. But we could also say every time x increases by 1, meaning every time we go to the right by 1, we're going negative 2/3 in the y direction. So every time we go to the right by 1, move 1 to the right, we're going down by 2/3. Okay. So that's slope-intercept form. And the really nice thing about that is you can see the y-intercept, plot it, you can see the slope and just use that to find your next point. And you can always plug in a value for x to get a value for y to find another point on the line, just to make sure you've got everything correct. When you do that, I suggest you actually use your original equation. So we can go back into our original equation. We can plug in that y. We can plug in x is 0, y is 2, and make sure that's true. Then we know that point's there. We can plug in the point x is 3, y is 0, and that will also make this equation true. So if we want to find the equation of a line, if we have the slope and we have the intercept, it's pretty easy, right? We can just use the slope-intercept form. But if we don't have that, if we just have, say, 2 points, or we have some point that isn't the intercept and the slope, then we're going to want to use point-slope form. Point-slope form is this right here, this equation right here, where the stuff in blue are the coordinates of one point, and this purple M is the slope. Okay. Sometimes you might just have 2 points, in which case you're going to have to calculate your slope first. Okay. But let's say we've already calculated our slope. We'll just use one of our points and the slope. That's enough to graph the line. So it is also enough to find the equation of this line. We'll plug in the point, the coordinates of the point and the slope. Again, remember, these are negatives. These are subtractions in our equation. So we want to make sure that we are subtracting when we plug in. And if we're subtracting negative numbers, so be it. Okay. So we take a point and our slope, and we can plug it into this point slope form and simplify it to get our equation in slope intercept form. Okay. Notice how our intercept is 0, y equals 0, x equals 0, and our slope is 1/2. Now, if we're just given 2 points, it only takes 2 points to define a line. As you notice, once we have 2 points, we can put a straight line through them. So for that reason, we only need 2 points to find the equation of this line. First, we have to calculate the slope. Be very careful with those negative numbers. So here our slope is -1. And you can see from the slope of the line, we're going down by 1 every time we move to the right 1. So that's a -1 slope. Once we know that our slope is -1, we can just use either of our points, but we only need one of our points, and it has to be just 1 point, to use slope or point slope form. So in this case, I'm going to use the point -2, 3. I could also use the point 2, -1, but I can't mix and match. So both the x and y coordinate need to come from the same point. We plug everything in, and we can simplify again to get ourselves into slope-intercept form. And from there, we can kind of check, okay, yeah, our intercept is at +1, where y is +1, and our slope is -1, meaning we are decreasing by 1 every time we move 1 step to the right. Right. We could use that other point, the 2, -1, and we would end up with the same answer. Right. Let me just explain parallel and perpendicular lines. On the left here, we have parallel lines. Parallel lines have the exact same slope. Okay. So in these 2 equations, y equals 2x + 2 and y equals 2x - 1, these equations, these lines have different y-intercepts, but the same slope, and for that reason, they run parallel to each other. Perpendicular lines, now perpendicular means that they cross at a 90-degree angle, okay? Perpendicular lines are going to have slopes that are negative reciprocals of each other. So not only do we have to flip the fraction or make a fraction out of whatever whole number is our slope, but we also have to make it a negative number. So let's just recap what we did here in section 3.3. We talked about the slope intercept. So that is y equals mx plus b, where m is the slope and b is the y coordinate of the y-intercept. Then we have our point slope form. Y minus one of our y coordinates equals the slope times x minus the corresponding x coordinate. So here m is the slope, x1 and y1 are a single point on the line. Now, if we rearrange it and say our x term plus our y term equals a constant, that's what we're going to call standard form. Okay, and in standard form, we always want our a to be positive, even if that means we're going to have to multiply the whole equation by -1. And then I think you might have noticed, but I'm just going to clarify here. To create a line, we only need one of the following. 2 points on that line. If we have 2 points, we can find the slope, we can find the equation, we can graph it. Or if we just have the equation of the line. If we have the equation, we can find the slope, we can find points on it, and we can graph it. Or if we have a point on the line and the slope, sorry, I missed the slope there. If we have a point on the line and the slope, then we can find the equation. We can find the more points on the line and we can graph it. Okay. And finally, the last thing I want to touch in this section 3.3 is vertical and horizontal lines. Vertical lines, basically for a vertical line, it can take on all the y values, but the x value is going to be fixed at a single x value. So this green equation, x equals some constant term, is a vertical line that occurs at the point where x equals that constant term and at all the points where x equals -1. So x equals -1 all along this line, and y can take on any value it wants because y is not specified. Now, a horizontal line is going to be y equaling some constant term. Now, that line is going to exist everywhere that y equals, in this case, 3. So y equals 3 along this whole line, and x can take on any value it wants because x is not specified. All right, that is the end of our section 3.3 lecture.